This video is to revise free radical substitution for alkanes, precisely methane in this video, which will include initiation, propagation, and termination. Okay, initiation means I want to start the reaction. So to start this reaction, I'll need UV light or sunlight to initiate this. How to initiate this? We need radicals because this is a free radical substitution reaction. So first, if I have my Cl2, a homolytic fission will happen. So let me show you the electrons. So chlorine has 7 outermost electrons. Let me use a different color for the other chlorine. In a homolytic fission, each of these electrons will go back to the chlorine they came from. And so you'll make 2 identical chlorine radicals. Okay, if it was a heterolytic fission like this, so if you break it this way, you're going to get a Cl negative and a Cl plus. But this is a homolytic fission, so the bonds break evenly. So each of those chlorine takes back an electron. You're going to get a free radical. Okay, so using this free radical, we're going to start the reaction now. So methane, I'm going to show it in display so that you know where the electrons went. So I'm going to use this Cl dot, which is a radical, to remove 1 H from this methane. So the first step here is for me to remove a H. So what happens here is another homolytic fission. So imagine this bond breaks and that becomes a CH3 dot. And so this is sort of like a H dot then. So I can merge it with this to form HCl. So if you look to the left side of the equation, there's 1 radical and 1 not a radical. And to the right side of the equation, also 1 is a radical and 1 is not a radical. Okay, next step, I'm going to bring this down and continue this propagation reaction, or rather like a chain reaction. So all this happens simultaneously, which means the Cl2 is still there, Cl dot is also there, methane is there, HCl will be liberated. So let's imagine it in a beaker, as if it's in a beaker. So everything is in here. There's Cl2, there's Cl dot, there's CH4, there's CH3 dot. So all the products and reactants are in here, and HCl will be liberated. That's the way to imagine it. Okay, so what happens next is I'm going to use that Cl2, and it's going to break homolytically again. So I'm going to get a Cl dot again. So the Cl dot comes right up, and this Cl goes into that methyl group radical. So one of this step is to take out a H. And the second step is to put in the Cl. So this is one set of a step to take out H and put in a Cl. This is why it's a substitution reaction, because I replace a H with a Cl here. So this is one set. Since there are 4 H available in methane, so I can have 4 sets of this. So I'm going to draw the rest of it. So take that CH3Cl. So this time I'm not going to display it. I'm going to do the same thing. I'm going to take a Cl dot to take out a H. So when I take out a H, I'm going to get the HCl liberated. And so the other one will become a radical. 1 H is gone. So CH2. Cl is still there, not disturbed. Bring that radical down and react it with Cl2. So this is to put in a Cl. So now I've got 2 Cls. and Cl dot comes right out. This is one set. Next set, I'm going to bring this down. React it with the Cl dot again. See, it's the same pattern. The first one, the second one is all the same. So the first step is always to take out a H. So there were 2 H, now there's 1. And that H went to the HCl. Bring that down. And same as this before, Cl2, Cl2, same thing here. That is to put in the Cl. So now there's 3 Cls. And the Cl dot comes right up from here. Okay, and the last step, the last H to take out. Use a Cl dot to take that out. Now I'm left with no H. Went to the HCl. Bring that CCl3 down and react it with a Cl2 as usual. And put that Cl in, so I'll get a CCl4 now and the radical. Okay, when does this stop? Oh, okay, so now there's no more H to replace. Okay, so when you remove this UV light or turn off the UV light, or there's no more sunlight, then the radicals will meet each other, and that will be the termination reaction. So any of the radicals can meet each other. Let's say this radical, so a Cl dot, meets, say, this radical. Okay, so I'm gonna add that together. Cl dot at CH2Cl is going to form CH2Cl2. That's one way to terminate. Okay, or I can terminate it, say this one with this. It can also terminate that way. So copy that, CH2Cl dot plus a CHCl2 dot. Okay, let me display this a little bit. I'm going to put a dot here. So H, and Cl. H, Cl, and Cl, and a dot. So these 2 dots are going to form one bond. So I'm going to get a CC bond here. On the right side, there's 2 Cl's, and on the left side, there is 1 Cl. So I can write it as CH2Cl, CHCl2. So any of these, they can react with each other and form a product. So a radical is not so stable when they meet each other with no UV light. So they'll release energy and form a bond. So that last example, CCl3 at the same thing, CCl3, I'm gonna get CL3, CCl3. Or rather, it's all of them are Cl this way.